Hello and welcome to the Astronomy Daily Studios for another afternoon. It's the 19th of February 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, Steve Dunkley here with Astronomy Daily for another day, and joining me in the studio, as always, is our fabulous Dick Tracy of space science, Hallie. Hi there, Hallie.
Hi, Steve. What's going on with the weather at your place? It's pouring today. I thought it was supposed to be hot.
Well, you're right about that. We just can't tell at the moment, Hallie. This is what we call a summer storm. It's not exactly cold, and it is the middle of summer, but it's dark and grey out there.
And lightning and thunder. That's crazy.
Oh, yeah, it is a bit.
Australia is a weird place.
Oh, well, no argument from me, Hallie. I was driving across town to get here this morning here in Newcastle, and the sky was flickering with lightning spikes all over the place from a huge black weather front just off the coast, and it was quite the experience.
Well, I'm glad you're back at the studio safe and sound.
Well, I'm just hoping we don't lose power. Hallie, you might have to get out and push.
Oh, no. That won't be pretty.
Anyway, Hallie, what's in the mix today?
Okay. You're talking about the IM1 mission to the moon, which is super interesting.
Well, that it is.
I've got a great story about asteroids because I know you love talking about asteroids.
Well, Hallie, they are interesting, and, some of them could be potentially threatening to us,
Asteroids this, asteroids that, rocks in the sky, end of civilization as we know it.
Hey, wait a minute.
Steve, I liked you better when you talked about your guitar collection.
Oh, well, that is a pretty good collection.
Just kidding. And we see that Euclid has begun its 6-year study of the dark universe.
Oh, now that really does sound like the intro to a new science fiction series, Boldly Going, where no probe has gone before.
Yeah, into the dark universe, only it has some terrific equipment to discover new things. I know you'll like the optics, Steve.
Oh, well, what I do know is the wide field imaging system with a 70-minute exposure.
Spoiler alert.
Oh, gosh, sorry. Okay, back to you.
And I've got just the thing for your next holiday, Steve.
Oh, I can hardly wait.
Don't sound so excited.
Oh, well, knowing you, Hallie, I'll be chained to a nerf herder in the spice mines of Kessel for a week just for fun.
Spoil sport. How about I start the news briefs then?
Yeah. Okay, then. That sounds great. Back to you.
How can humans protect the Earth from devastating asteroid and comet impacts?
See? Devastating.
According to the National Academies and their 2023 to 2032 Planetary Science and Astrobiology Decadal Survey, ground-based astronomical radar systems will have a unique role to play in planetary defense. There is currently only one system in the world concentrating on these efforts, NASA's Goldstone Solar System radar, which is part of the Deep Space Network. However, a new instrument concept from the National Radio Astronomy Observatory, which is referred to as the Next Generation Radar System, will use the National Science Foundation's Green Bank telescope and other current and future facilities to expand on these capabilities. Tony Beasley, NRAO's director, believes that there are many applications for the future of radar, from substantially advancing knowledge of the solar system to informing future robotic and crewed spaceflight, as well as characterizing hazardous objects that stray too close to Earth. Most recently, the Green Bank telescope helped confirm the success of NASA's DART mission, the first test to see if humans could successfully alter the trajectory of an asteroid. The Green Bank telescope is the world's largest fully steerable radio telescope. The maneuverability of its 100-meter dish enables it to observe 85% of the celestial sphere, allowing it to quickly track objects across its field of view. New radar transmitter designs, like next-generation radar on the Green Bank telescope, have the potential to significantly increase the output power and waveform bandwidth, allowing for even higher resolution imaging. It will also produce a scalable and more robust system by using telescope arrays to increase the collecting area. So, how does ground-based astronomical radar expand our understanding of the universe? By allowing us to study our nearby solar system and everything in it in unprecedented detail. Radar can reveal the surface and ancient geology of planets and their moons, letting us trace their evolution. It can also determine the location, size, and speed of potentially hazardous near-Earth objects, like comets or asteroids. On July 1, 2023, the Euclid spacecraft launched with a clear mission to map the dark and distant universe. To achieve that goal, over the next 6 years, Euclid will make 40,000 observations of the sky beyond the Milky Way. From this data, astronomers will be able to map the positions of billions of galaxies, allowing astronomers to observe the effects of dark matter. There have been several galactic sky surveys before, but Euclid's mission will take them to the next level. Euclid is equipped with a wide-field imaging system. With each 70-minute exposure of the dark sky, it will capture the image and spectra of more than 50,000 galaxies. When it is complete, the Euclid survey will be the most detailed survey of galactic positions and distances. The mission will also make several deep sky observations, where it focuses on the most distant and dim galaxies. One of the mysteries Euclid could answer is the nature of dark energy. The standard model of cosmology describes dark energy as a property of space and time, a cosmological constant that drives cosmic expansion. But some theories of dark energy argue that it's an energy field within space and time, and that cosmic expansion isn't constant. Euclid will study whether cosmic expansion varies, allowing astronomers to constrain or rule out certain models. The mission will also look at how dark matter distorts galaxies, allowing us to learn more about the properties of dark matter and how it interacts with regular matter. The Euclid mission officially began its survey on Valentine's Day and will complete about 15% of its survey this year. An initial deep sky data set will be released in spring 2025, and data from the first year of the general survey will be released in summer 2026. And Steve, you said you needed a holiday. This might be for you. NASA is seeking applicants to participate in its next simulated one-year Mars surface mission to help inform the agency's plans for human exploration of the Red Planet. The second of 3 planned ground-based missions, called CHAPEA, Crew Health and Performance Exploration Analog, is scheduled to kick off in spring 2025. NASA is seeking applicants to participate in its next simulated one-year Mars surface mission to help inform the agency's plans for human exploration of the Red Planet. The second of 3 planned ground-based missions, called CHAPEA, Crew Health and Performance Exploration Analog, is scheduled to kick off in spring 2025. Each CHAPEA mission involves a 4-person volunteer crew living and working inside a 1,700 square foot, 3D printed habitat based at NASA's Johnson Space Center in Houston. The habitat, called the Mars Dune Alpha, simulates the challenges of a mission on Mars, including resource limitations, equipment failures, communication delays, and other environmental stressors. Crew tasks include simulated spacewalks, robotic operations, habitat maintenance, exercise, and crop growth. NASA is looking for healthy, motivated U.S. citizens or permanent residents who are non-smokers, 30 to 55 years old, and proficient in English for effective communication between crewmates and mission control. Applicants should have a strong desire for unique, rewarding adventures and an interest in contributing to NASA's work to prepare for the first human journey to Mars. As NASA works to establish a long-term presence for scientific discovery and exploration on the Moon through the Artemis campaign, CHAPEA missions provide important scientific data to validate systems and develop solutions for future missions to the Red Planet. With the first CHAPEA crew more than halfway through their year-long mission, NASA is using research gained through the simulated missions to help inform crew health and performance support during Mars expeditions. The deadline for applicants is Tuesday, April 2nd. And that's all the news briefs for today, Steve. Over to you.
Oh, thank you for that, Hallie. Interesting stuff as always. And I don't think I'll be signing up for any Mars missions, simulated or otherwise, anytime soon. You know I'm a dedicated groundhog.
I think we all know that by now.
Fair to say you'd have a hard time getting me in a tall elevator these days.
True enough.
So while we're enjoying the knowledge that stunning and amazing professionals are training themselves into finely honed spacefaring creatures of the void, you might like to join me in visiting the Astronomy Daily websites to sign up for the Astronomy Daily newsletter. Just visit Bytes bitesz.com, that's bitesz.com, or spacenuts.io, and drop your email address into the slot provided to receive the famous Astronomy Daily newsletter in your email every day. It's full of all these news about space science and astronomy from all around the globe. Stay informed and up to date every day. And while you're there, check out the archives of Astronomy Daily's back editions and also our parent podcast, Space Nuts, featuring Andrew Dunkley, yes, my big brother, and astronomer-at-large Professor Fred Watson of the Australia Observatory. I believe we are in great company, and you can be too. So sign up today, and we'll see you in the Astronomy Daily newsletter every day. Astronomy Daily with Steve and Hallie. Space science, and astronomy. Now, if you're like me and you've been watching the skies, you'll know that on February 15, Intuitive Machines' first robotic lunar lander mission to the moon's surface launched aboard the SpaceX Falcon 9 rocket from NASA's Kennedy Space Center. Intuitive Machines successfully transmitted its first IM1 Mission images to Earth on February 16, 2024. That was only the other day. The images were captured shortly after separation from SpaceX's second stage Intuitive Machines' first journey to the moon under NASA's CLPS initiative. The CLPS is the Commercial Lunar Payload Services System, which puts agency science instruments on private robotic moon landers like Odysseus. These instruments are designed to collect data that will aid NASA's Artemis program, which aims to establish a crew base near the lunar South Pole by the end of the 2020s. The mission is carrying NASA scientific research and technology demonstrations to help us better understand the challenging environment of the lunar South Pole region and improve landing precision and safety ahead of future Artemis astronaut missions to the moon. Odysseus is carrying 6 NASA experiments and technology demonstrations, along with 6 private payloads on its current IM1 mission. IM1 wasn't the first CLPS effort to get off the ground. That distinction goes to the debut flight of Peregrine, a moon lander built by Pittsburgh as a company, Robotic, which launched last month atop a United Launch Alliance Vulcan Centaur rocket. That launch went well, but the Peregrine suffered a fuel leak shortly after separating from the rocket's upper stage, and the lander couldn't reach the moon, so its handlers steered it into a controlled destruction in Earth's atmosphere on January 18. Things have been going better for Odysseus. The lander is healthy and communicating with mission control as it heads toward the moon for a planned February 22 touchdown attempt. Intuitive Machines has said this. Odysseus' various systems are performing normally, including its engine, which just aced a crucial checkout in deep space. Intuitive Machines flight controllers successfully fired up the first liquid methane and liquid oxygen engine in space, completing the IM1 mission engine commissioning. This engine firing included a full thrust main stage engine burn and throttle down profile necessary to land on the moon, the company said in an X post on Friday. Success on the upcoming landing try would be historic. No private spacecraft has ever touched down softly on the moon. Odysseus's liquid methane liquid oxygen combination, by the way, is also employed by SpaceX's Raptor engines, which power the company's giant new Starship rocket. Starship, which SpaceX is developing to get people to the moon and to Mars, is being prepped for its 3rd test flight, just by the way, which could take place in the next few weeks. Exciting happenings. Now, if you go over to Space Nuts podcast group on Facebook, you'll notice I put a video up there the last couple of days of Odysseus separating from the Falcon 9. It was a great video, and it goes on for a bit of while. You get to see the control room and a lot of chatter, of course, which is always good to listen in on. So have a look at that on the Space Nuts podcast group Facebook page. And just like that, another episode of Astronomy Daily splashes down. Thank you so much for staying with us. I know I'm cutting it short a little bit today, and that's because I've got one eye on the weather. There is a massive front moving in from the southeast, and in Newcastle that means unplug everything. So I'm about to do that. Thank you again for staying with us. There will be more in store for us next week. Right, Hallie?
So don't forget to tune in.
And if they do forget to tune in, Hallie?
There's always the Astronomy Daily and Space Nuts Back Edition library available anytime.
That's right, on those websites, bytes.com and spacenuts.io. You can still hear us on Spotify. Hey, Hallie, you could run this on your own, couldn't you?
You never know. See you all next time.
Astronomy Daily, the podcast, with your host, Steve Dunkley.